Hi, I hope you're all doing well. Today we're going to continue our lesson on object-oriented programming, and we're going to talk specifically about ways to store objects and how to extract information from data structures that contain objects. So specifically, we're going to focus on building a contacts list. And this programming is very similar to how your own contacts are stored locally on your phone. So whenever you want to add a new contact, right? Well, let's think about what a contact is first. So a contact has things like has a first name, has a last name, a phone number, and then optionally you can add maybe an email or a company that that person works for, right? So these are the things that make up, that like characterize our contact object. So we also, when we're thinking about our contact list, we need to think about ways to store our contacts, right? And a contact list is essentially what it is, right? We should work with a list. Why? Because lists, again, you can store repeating, you can store things that have like repeating names, yeah, lists are just a great way to store our objects. But first, before we actually store our contacts, we have to declare what the contact object is, right? So over here, again, we have our constructor, and we don't necessarily have any class attributes. We mostly have instance attributes because there isn't anything I can think of that's like unique to a contact. That's unique to every contact, right? Everything that we put in is like unique to one contact. Obviously, though, in more sophisticated models, you might have class attributes. But let's see what it looks like. So again, remember we have to have self in our constructor, the first thing. Take in a first name, last name, a phone number, possibly an email, possibly a company. The reason I declare these initially as none is because we're saying like we can have a constructor that doesn't take these parameters in because they're optional. However, if they are not none, then we're going to see what happens. So over here, the default, though, by saying equals none, we're just saying the default is that it's none, it's empty. So here, again, we just assign the instance attributes to our parameters, right? I created another instance called full name, and that's like first name, last name. Phone number, right? And then here, this is what's special, is like the email is, it's equal to our parameter email if it's not none, right? Else, we're going to set email to none. And the same thing for company. If it's not the default, so if it does have a value but it's not none, set that equal to company, whatever our parameter company is. If it is none, then just set our instance attribute to be none. So when we actually think about how we're going to reference or instantiate our object, when we think about how we're going to have our constructor, right? Again, we have the class name. And then there's 4 different ways that we can write this, right? We can have everything filled. So we can have a first name, last name, phone number, email, company. Our second option is just like we don't have an email. And note that we have to be explicit when we reference the name of the variable company, because the order matters. So see over here how company is our last variable parameter. If we just said company without anything, then it'll actually think it's email because email comes before company. So we have to be explicit. Again, we can also have just email, right? Or we can have a contact with no email or company, and then we just have the requisite parameters, which are the first name, last name, and phone number. Cool. All right. So let's think about again how to store this. And very simply, all we need to do is just first instantiate an empty list. We have to create our contacts. So I was having a bit of fun here. I referenced one of my favorite actresses, Zira Wasim. She did a lot of Bollywood movies. I think she retired from the film industry. But yeah, so like I put in a random phone number, a random email, and then, oh, her company's acting school, right? The second contact I put is Ahmed Zuel, who's like a famous Egyptian chemist who won the Nobel Prize in Chemistry for femtochemistry. So I put him with his phone number and an email. You see how I didn't put in a company? I just because maybe I don't have his company. And then to add to this list, all we need to do is just put brackets to say that we're appending a list to a list, and then we're gonna add new contact, second contact, which are over here, which we created. Add those to my list. Now, I actually want to search in my list, right? So how do I do that? And then at this point, we're going to cover binary search, which is an optimized way of doing search. It's a recursive function because I want to have a function that I can just put in the name, let's say first name, and then pull up my contact object just from searching for their first name, which is how search works in your own phone. So the pseudocode for binary search is that, or the pseudocode for this is I'm gonna do a binary recursive search to find the first instance of the contact whose name matches my query. Then I'm gonna check if that contact has an email. If so, get their email, and then print their email to the screen. So, okay, binary search is broken down into two main things. So binary search, you first basically have to sort everything in your list. And this is a way to sort everything in the list by first name. So I'm sorting it by first name. This code snippet over here sorts it by first name. Then I define my binary search algorithm as taking in 4 parameters. The input array, left and right. So left and right are indices. Usually you want to specify the left as being your first index, which is 0, and your right as being your last index, which is 1 minus the length of our list. And then x is whatever we're searching for. So that's our query. So the way we break it down is like, remember, we have it sorted, right? So we sorted it alphabetically in this case. So if I were to sort it here, if I had a list of like 3 contacts whose names were Alfred, Sarah, and Michael, it would be sorted such that it was Alfred, Michael, Sarah, right? So we go in having sorted our list. Now, let's go into the recursive function. We check the base case. The base case, essentially, what we're doing here is essentially we're going to break our function in half such that we're going to break our list in half, such that we find a middle point. And because it's sorted, we can just first check different things depending and eliminate different halves of our function of our list because we know, well, if our list is sorted, we first have to check if it's if our middle point, so if we find the middle point, right? And the base case over here is that like we always have to check that if the right is greater than left, meaning that if my right index is 9 and my left index is 0, this has to be satisfied, right? We define a middle point, and the middle point is just taking the difference divided by 2, right? That's our midpoint. So if our element is present at the middle itself, then return. We found our query. We find the result of our query, right? So if our index, the middle index of input, if the first name of that object, right, because again, we're working with a list of objects, is equal to our query, return. If not, so then we check and see if our middle point, right, if it's greater than our search, meaning that if our search, let's say you have a list of like 9 numbers and the search number I'm looking for is 3, if my search is, if my midpoint is 5, or because I think we're doing, I think it's 4. Yeah, if our midpoint is 4, because 5 is greater than 4, we're going to check the, we're going to skip this because our midpoint is less than our query. So then we check the right-hand side, right? And you see how like we simplify the problem because we only check a 1/2 of our entire array and not the other. We eliminate it because we know if we sorted it, if I have a list of 9 numbers and my query is 5 and my midpoint is 4, it can't be anything between 0 and 4, right? Because that's all, we sorted it and 5 is, we know, is greater than the midpoint. So then we only check everything from 5 to 9, right? So yeah. You see how that, and this simplifies our programming. It simplifies the time complexity of this function, and it's a very efficient way to do search. Now, if you've exhausted both of these, right? And again, here the point is that we call the function recursively. So then if we like only check the right half of our original function, or of our original list, sorry, we then break that right half into a left and right half. And then we again iterate the same process, to find the midpoint of that subhalf, and then check if it's greater than or less than the midpoint, and then again repeat this process. So this is a very efficient way to do search. And then if we've exhausted both of these, then we know that we don't have anything, like our element is not present in the input, return -1, right? Meaning that return that we haven't found our email, like that contact is in our list based on our search. So over here, what I'm going to do is I'm going to declare the index of the object as of our contact as being the index from our binary search. So I think I did it such that I would search by the index. Yeah, it would return the index. So it's the type that it returns is an integer. So you find that from the search. Then just say that my selected contact is the index at, like, the element that is at index of contact in our list. Then if it has an email, if it doesn't have an email, or sorry, if it does have an email, then print her email, right? If not, print 0 does not have an email stored. And then we see, oh, it has an email. So the next thing that we're going to do is you want to have we want to build a song player. So this, again, you can just go to the link in the description box below, click on this button, it'll take you to an assignment that helps you build some sort of like MP3 storage program that helps you store and play song files. It's very interactive, very fun, it's very simple. Yeah. Again, thank you so much for your time. Next, we'll be covering making plots and plotting in Python, which I think is really fun for data analysis. Yeah, again, leave any questions or concerns, comments in the comment box below. Be sure to like and subscribe. Be sure to click on the link and then see the entire lesson to interact with it at your own pace. Yeah, see you next time.